For their new flagship printer, Bambu Lab's mission was simple. Just build a bigger X1C and everyone would be happy. That's not the Bambu Lab way though, and instead of giving us the 3D printer that we were asking for, they surprised everyone by releasing the H2D, a dual nozzle heated chamber powerhouse that makes the idea of just a bigger X1C look quaint. Stay tuned as we delve into how Bambu Lab's decision to chart their own course led to their most innovative and uniquely compelling printer to date. This video is sponsored by PCBWay. Rather than just list all of the specs of this innovative machine, I'm going to focus on two main questions. What can the H2D do better than other 3D printers, and what are its flaws? As believe it or not, it does have some. In order to be able to answer these questions, I've put over 350 hours of printing on this machine already, and I found a lot that we need to discuss. If you do want to know absolutely all of the technical specs of the H2D, then I did already make that video when it was first delivered to me, which you can find here. But first, you may already know that there is a version of the H2D that comes with some bonkers add-ons, like a laser and cutting blades that allow it to do all sorts of things that other 3D printers can't, but I'm keeping it simple. In this video, I'm purely focusing on the 3D printing only version, but this doesn't mean that we're not going to have much to talk about. In fact, whilst the laser capabilities are grabbing the headlines, the major innovations are actually with the H2D's advancements in printing capabilities. I've split this video up into sections based on what I think are the main real-world benefits that the H2D brings, and in each of these sections I'll be trying my best to explain how and why it can do what it does, and show what it actually means for you in the results of what it can produce with printed examples. Before we go much further, I should just say that Bambu Lab sent me the H2D, I didn't buy it, and I am part of their affiliate scheme. What this means is that if you decide to buy something from Bambu Lab after clicking one of the links in my description, Bambu Lab will recognise that my video was in some way useful to you with a small commission. There's no cost to you, and my links will always take you to the best price, and it's a great way to support the channel without me having to ask for memberships or subscriptions for any of my content. However, if you believe that that makes me in any way biased, then bear that in mind when making any purchasing decisions. I feel that I try my best to provide honest reviews, and I make a point of never telling anyone to buy anything. But if after watching any of my videos you do decide to buy something, just remember that the affiliate links help in a small way to keep the channel content free to you. Right, with all that out of the way, let's dive in. Now, I know I said that Bambu Lab ignored everyone's request to make the H2D bigger, but that's not quite true. The H2D's actual build volume is 95% bigger than the X1C, Bambu Lab's previous flagship model, but the printable area on the bed is only 56% bigger. I still think that this is a good amount bigger, but from initial reactions, it seems that some people wanted even more. In a recent interview with Stefan from CNC Kitchen, Dr. Tao, Bambu Lab's CEO, explained quite well why they chose to go with a 320 by 320mm bed on the H2D. If you have the time and interest, then this is a great interview, but to sum up his reply when asked why didn't they make it bigger, Dr. Tao said that bigger means more power, lower quality, a bigger overall footprint, and more weight. Also, bigger is an easy thing to ask for, but how big is big enough? What they decided to do instead was look at what people wanted the bigger build volume for, and their conclusion was that some of the bigger items that people wanted to print were helmets for cosplay and wearable shoes. Very early on, I decided to test this out, and using some 90A TPU, I printed these shoes and a full-size Mandalorian helmet. Now, I did have some minor issues with these bigger prints, but we'll come back to that later. The main point is that the H2D is big enough to print these commonly requested items in one go. As Dr. Tao alluded to, one of the downsides to a bigger build volume is a bigger overall printer, and the H2D is pretty huge. If you're looking at buying one, then make sure that you have room not only for its bigger footprint, but also for its much larger height, especially if you put an AMS filament holder on the top, like I do. Another large print that I completed with the H2D was this lidopane lamp for my son that enabled me to upcycle something that otherwise would have ended up in the bin. This print was actually the very first lidopane I ever printed, and I learned a lot during the process. From the results of this and some of the other prints I was beginning to reel off, it was clear that Bambu Lab seemed to have managed to not only maintain the print quality with the bigger build volume of the H2D, but actually improve things over their previous models. VFAs, or vertical fine artifacts, were unfortunately quite common on earlier models, but from the test prints I completed with the H2D, they seem minimal, or you could even say completely removed. Unfortunately, there is currently a small bug with Bambu Studio, the slicing software you need to use, which prevents a varying speed VFA print to be produced, but I printed manual ones at different print speeds with pretty exceptional results. Bambu Lab is able to achieve such high quality results on the H2D with a combination of hardware and software. Instead of a dumb stepper motor, the H2D has a permanent magnet brushless servo motor controlling its extruder. What this basically means is that the extruder motor, which controls how the filament or material that makes up your print is squeezed out, can provide feedback about how well it's able to do what's asked of it. What this means in real terms is better control, which is a bit of a theme through the H2D. There are lots of other minor hardware tweaks all through the H2D that contribute towards substantially better control, like steel linear rails instead of carbon rods and the active chamber heating and cooling that we'll get to later, but the software also plays a big role in improvements. Instead of upgrading the full motion system with ultra precision components that would have bumped the H2D's price to industrial printer levels, Bambu Lab used some clever AI and algorithms on this machine to account for any inaccuracies in any of the hardware and adjust the output to avoid any loss in actual print quality. From what I've seen so far, this works very well. The finished surfaces on prints are of a very high quality over a wide range of materials. There is also the option of improving accuracy further by using a plate called a vision encoder, which allows the printer to accurately calibrate itself to a point where it can reportedly achieve 50 micron accuracy. I don't have the ability to test and measure this, and at no point with any of my test prints did I even feel the need to use the vision encoder that I was sent. The vision encoder is around $100 and it isn't included, so it's a relief that 90% of users won't need it, but it is there for anyone wanting that final tightening up of any tolerances. What I did notice quite quickly with print dimensions is that internal bores are much more accurate than on other printers. I, like anyone else trying to design parts that need to fit together, have become used to allowing around a 0.3mm gap in designs that are going to be printed to avoid an interference fit. If you get a H2D, you can straight away reduce that gap between parts down to 0.1mm at least, in my experience. There are no mind-blowing print speed advances with a H2D like we saw when Bambu Lab released their first printer. Instead, the already super fast speeds have been consolidated and the focus has been on maintaining or improving quality with the larger build volume, which very much seems to have been achieved. The stated maximum toolhead speed is 1000mm per second, but you won't be printing at that speed. The actual print speeds are more limited by filament than printer hardware these days, so as they say, results may vary. There are some pretty sizable reductions in the time it takes to print some things with this machine, but it uses another trick for that I'll get to soon. If the filament will take it, then the standard nozzles are capable of achieving a flow rate of 40mm³ per second, and there are also high flow hot ends that increase this up to an astonishing 60mm³ per second, which should also mean that we can use bigger nozzles without worrying about the printer keeping up when it comes to getting the filament hot enough. If you've owned a 3D printer before, then the chances are that at one point or another you will have felt the disappointment of a failed print. There are a million different reasons why a print might fail, but it's fair to say that most of the failures could probably be avoided or at least recovered if you were sitting watching the whole print from start to finish, ready to hit the pause button. Doing so would obviously be a waste of time though, so just like many people looking to streamline their own efficiency these days, the H2D farms this task out to AI. Using 3 different cameras, this printer constantly scrutinises every print looking for any hint of things not going to plan. When it sees something it doesn't like, it pauses printing and sends you a message to say that something's wrong. It can be a little overzealous, like when it kept pausing my TPU shoe print because of suspected clumping of filament on the nozzle, which at one point prompted a 3 AM trip to my workshop to reassure it that everything was going to be okay. It was at this point that I dialed down the sensitivity at the cost of a little stringing, but it was good to have the opportunity to make a decision rather than potentially losing a 4-day print should the issue have been worse. One print where the AI genuinely did save a long print from failing was this Mandalorian helmet. Unfortunately, I did have some minor bed adhesion issues with the H2D on a very small number of prints, and one of the support towers on this print fell over about 24 hours in, and again while I was asleep. The AI paused the print, however, which enabled me to bodge up some rudimentary supports with some tape, which allowed the print to complete. This not only saved me a day of print time, but also a lot of filament, so I was very pleased to have it pause for me to check things out. It also has an LED status light strip on the front edge of the bed, which doesn't add too much when you just have one printer, but I can see how it would be a benefit to anyone with a print farm full of H2Ds. One of your printers sitting there with a flashing red light would get your attention much quicker than a small warning up on the screen. Another way that the AI has got your back is by double checking the printer's hardware configuration before it starts a print. With the use of things like QR codes on the bed and nozzles, the H2D double checks that you do indeed have the 0.6mm nozzles or the textured PEI print surface fitted, as the settings in the slicer may say. I'd like to say I don't get things like this wrong, but I do, and I did on one of my test prints, but the AI soon caught my mistake. It will also look out for random items left on the bed or any prints you forgot to remove before starting the next one. All in all, the AI features work well without being too intrusive, and you have the option to dial down the sensitivity or even turn it all off if you want to. All of the belt and braces AI checking and monitoring on the H2D have helped ensure that, even though not everything has been perfect, the only actual print failures I had in all of my testing was when I was deliberately trying new experimental ways of printing and ignoring the AI warnings. Next time you've got a new electronics project, upload your Gerber files to our video sponsor PCBWay's online portal and receive an instant quote. With no minimum order required, boards shipped via DHL, FedEx, UPS or sea freight in as fast as 24 hours. Their one-stop solution covers PCB fabrication, assembly and SMD stencils under a single roof, backed by ISO 9001 and UL certification for reliable quality. Get started today at PCBWay.com. It's great to see that the days of manually leveling the bed or setting a Z offset are firmly behind us, and just like Bambu Lab's other recent printers, there's nothing to do after plugging the H2D in other than entering your Wi-Fi details and then waiting for the automatic setup to complete. There are a couple of extra calibrations that are needed with this new machine compared to others though, and that's because of one very key feature that the H2D has that you won't find on competitors' machines. I'm surprised it's taken us until now in the video to talk about it, but the H2D has not one but two hot ends. These hot ends are on the same print head, and whilst Bambu Lab is not the first to do this, they are making it work way better than anyone else. As I said earlier though, we're not just going to talk about what bells and whistles the H2D has, we're looking at why it has them and what they do, and there are a couple of reasons why two hot ends are better than one. Over the past couple of years, there's been an explosion in the amount of 3D printers that let you use multiple colours of filament in one print. The way pretty much all of them do this is to perform a filament swap, which usually involves pausing the print, cutting the filament above the hot end, pulling the cut filament back, and then replacing it with a new colour of filament, which is then used to push through what's left of the old filament, which is discarded. This discarded blob of filament is affectionately known as poop, and when you can sometimes have multiple filament changes per layer of a print that can itself be made up of hundreds of layers, the amount of wasted poop can get a bit ridiculous. With two nozzles, there's no need to cut and retract the filament each time you change filament, you just switch to the other nozzle. Of course, this only fully eliminates the poop if you only have two different colours in your print, but it also still saves a lot when you use more than one colour. Now, when you slice a multicolour print in Bambu Studio, it will suggest the best arrangement of filament to save waste, and it also tells you how much you'll be saving by using this arrangement and the H2D's dual nozzle system. To give you an example of the real world difference all this makes to filament savings, this is the waste material from this one print on a conventional single nozzle multi-filament printer. And this is the waste material from my entire 350 hours of printing on the H2D. Now granted, this isn't really a fair comparison, as I didn't print a huge range of models with more than two colours, but it's quite a stark example of how much other machines can waste swapping filament. Switching hot ends to change colour is also a lot quicker than the filament swapping and purging procedure for a single hot end, so there can be considerable time savings with the same print on the H2D just from the quicker material switching. The other main benefit to having two hot ends on your H2D is that you have the ability to print different materials in one print, as the hot ends can be operated at different temperatures. I'll cover this in a bit more detail in a minute, but first we need to look at why everyone doesn't just put 2 hot ends on their printers, or for that matter, why not have 4 and eliminate waste altogether? Well, as we've seen with the decisions made over the bed size, adding a feature often comes with a compromise or two, and the same is true of adding more hot ends. The first downside to adding a hot end to your print head is weight. In order for the print head to whip around at lightning speeds, it needs to be as light as possible. Adding more weight means that the print head has more inertia, so it's harder to get moving and then also harder to stop while still maintaining control. If you want to feel this effect yourself, try running in heavy boots versus light running trainers, and you'll see what I mean. In order to add the extra hot end without adding too much weight, Bambu Lab had to undertake some very careful slimming down of all the print head components and also try to add as few components as possible too. Through the use of clever mechanisms, Bambu Lab have been able to use just a 1 servo motor for extrusion on both hot ends. When the switch occurs, one set of extruder gears are disengaged from the motor while the other set is engaged. Left hot end is also moved out of the way when not in use, but this also brings another set of problems to solve. In order for the filament extruded from one nozzle to line up exactly with filament extruded from the other nozzle, the printer needs to know exactly where each nozzle is. Therefore, the hot end that moves up and down needs to return to the exact same place every time without fail, and there can be no deviation or you'd see lines in your print. One of the extra printer calibration procedures that I mentioned earlier is to accurately measure where each nozzle is in relation to the other one. The printer does this using a small sensor on the back of the bed that detects the position of each nozzle in relation to the printer's movements and then refers to this offset each time it switches. I wanted to see how accurate this calibration is, so I knocked up a quick model that changes between 2 different brands of black filament fed from 2 different hot ends every 5mm, and other than the surface appearance giving away where the changes happened, I can't really feel any kind of ridges or offsets in where the 2 nozzles were laying down material. I certainly didn't notice any offsets between materials on any other prints that use both hot ends, so it seems that Bambu Labs have done a very good job in lining up the 2 nozzles when printing. The hot ends themselves are very similar to the design I like so much on their A1 model, and they are quick to change. I must say though, the right hot end is a bit fiddly to remove with a small section of filament poking out the top, and I found it easier to remove the front cover of the print head when swapping. There are no wires to mess about with though, and as the filament is always cut just above the hot end, there's no need for the hot ends to be hot when you touch them, which is much safer than on some other models when you want to change to a different size nozzle. If you're new to 3D printing, then the main reason you might want to change the nozzle size on your printer is to either improve the quality of small details with a smaller nozzle, or to print more functional objects faster with a bigger nozzle. I wanted to print some replacement corner pieces for my son's football goal, but as it was more important for them to be strong than look good, I experimented with using different nozzle sizes and printing with Bambu Lab's PAHT filament. PAHT is a nylon that has good mechanical strength and layer adhesion properties, so it should be a durable material for use outside and to hopefully survive constant impacts from a football being kicked at it. Only time will tell how well these prints will fare, but the material printed as easily as PLA on the H2D with only one minor issue when one released from the bed just before the print finished. Thankfully the part is still usable though, and I was able to get a good reference for print time and quality for each different nozzle. With a 0.4mm nozzle, the corner section took 4 hours. With a 0.6mm nozzle, the print was finished in 3 hours and 20 minutes, and the 0.8mm nozzle saved another 10 minutes over the 0.6mm nozzle. It's clear to see the sacrifice in print quality here, but like I say, for purely functional prints, the sacrifice can be well worth it. Unfortunately, at the moment you have to use the same size nozzle in each hot end, which is a bit of a shame, but it's very likely to only be a software change to make it possible to use 2 different ones, so it's not out of the question that this feature may be added later. I was surprised to see that even on prints that only uses 2 filaments, one feeding to each hot end, that a purge tower is still needed. This is because even though there's a clever flow blocker that blocks the nozzle that's not being printed with to stop filament oozing, there's still a need to print an amount of filament to prime the filament pressure in the nozzle before starting to print for real. If it didn't do this, then there'd be a moment of under extrusion at any point the nozzle was switched. There are also a couple of other things to be aware of when it comes to what you can and can't print with each nozzle. It's recommended that the right nozzle be used as your primary printing nozzle, with the left one used for things like a different filament for supports, for instance. It's also recommended that if you only have one AMS or automatic material system, that you connect it to your right hot end. I tried the AMS on both hot ends though and had no problems other than a couple of occasions early on where filament failed to feed into the left hot end properly. This was fixed with a very slight rearrangement of the PTFE feed tube for that side, and I had no repeat for the rest of my testing. It's also recommended that you only use the right nozzle for flexible filaments like TPU, and if you do want to print with TPU, there are some other annoying hoops to jump through. The main issue with TPU filament is that it's very flexible, especially in the lower grades, and that means that, just like wet spaghetti, you can't push it down a tube with any success. The multi-material systems that feed filament to the print head need to do just this, which makes them incompatible with TPU. TPU also induces a lot of friction within the PTFE feed tubes on a printer, so it's always best to keep the filament route in PTFE tubes as small as possible. Bambu Lab's solution to this problem on the H2D is to bypass the AMS mechanisms and filament sensors when using TPU. This means that you need to disconnect and reconfigure some things for TPU printing. The amount you need to do depends on the material hardness. With the 95A TPU that Bambu Lab supplied, I was able to just feed one PTFE tube out of the special TPU hole in the back of the printer and run it to the external spool holder on the side of the machine. There is a TPU exit in the AMS HT that we'll talk about soon, but I couldn't work out a good place to sit this, so I went with the external mount. However, when trying to get the 90A TPU shoe print started, this route was still giving too much resistance. I ended up removing the printer's top cover and feeding the filament directly to the extruder inlet through a very short piece of PTFE tube just to keep it clear of all the printer's motion system. This means that to keep the moisture sensitive filament as protected as possible over the 4 or 5 days the print would take, I had to perch the filament dryer on top of a cardboard box, which gave me the best low resistance mount for the filament and as short a filament path as possible. Amazingly, this jerry-rig solution worked well for the full 4 days of the print, which was a relief as I only had one reel of this colour changing TPU. I have to say though, I've been blown away by this print. The design is on MakerWorld and I'll link to it in the video description, but the finished print feels like nothing else I've ever printed and I love showing them to people. I was also able to print the supports in PLA, which released leaving virtually zero evidence behind. This, combined with the clever changes in construction throughout the design, means that you're left with something very unique, and I think very few people would be able to tell you how it was made. Along with the lithopane lamp, these shoes are my favourite print from the H2D. This kind of model really captures people's interest in 3D printing, and it's designs like this that are going to inspire the next generation to get involved in design and manufacturing. It's these more varied uses for 3D printed items that excite me about our future, and a very big part of advancing 3D printing's usefulness lies in the materials that we're able to print with. 3D printing has become way more popular over the time I've been involved in the hobby, but I can't say I love its reputation for producing all of the easily breakable PLA toys that you now see en masse at every craft market in the land. My first experience of 3D printing was working on scale wind tunnel models for racing cars, and the ability to accurately produce and reproduce useful parts to develop designs very quickly gave me all sorts of ideas of the things I could make with this new technology. Unfortunately, it's taken a long time for printers that can actually produce strong usable components to become affordable enough for me to own. The H2D has helped advance things on another stage in this area, and whilst it's far from the first 3D printer to be able to print with materials like nylon, PPS and others with fibre reinforcement, so far, for me, it's the most easy to use that can print with these industrial materials. Whilst you need high nozzle and bed temperatures to print with stronger materials, high temperatures alone are not enough. You also need to carefully control the temperature of the air around the print as it grows. The H2D's nozzle can reach 350 degrees and the bed can reach 120 degrees, but with the H2D you also have a chamber heater that's capable of maintaining an air temperature around the print of 65 degrees. Again, there are other printers like the Chidi Plus 4 that can match these specs, but pairing these temperatures with the ability to print support material in a different, easy to remove filament makes the H2D way more versatile in my book. This is exactly what I did with the football goal pieces. The printed part was in PAHT, but if I'd printed the supports in the same material, they would have been very difficult to remove and need finishing to achieve the dimensions I needed. Instead, using the other nozzle, I printed the supports from ASA, which simply fell away as soon as the temperature dropped, leaving well-dimensioned parts. Not only can the print chamber be heated for filament that likes things hot, but it can also be cooled when printing with anything that doesn't like the heat, like PLA. Previously, the advice when printing with PLA and even PETG in an enclosed printer was to leave the door open and remove the top panel to allow heat to escape, but you don't have to do that with the H2D. With the clever use of an automatically opening front vent and extraction vents on the back, external air can be drawn in and around your print chamber without the need for big openings. The air that's pulled through the exhaust is also filtered, which means you won't be unnecessarily exposed to any nasty particulates that might be produced from the material you're printing with. Another trick that the H2D can do with mixing materials in a print is to give a part different properties in different areas by using different materials. As an example, I run a NAS, or Network Attached Storage Server. This is basically a simple little storage computer that sits in the corner of my office that contains a number of mechanical hard drives. Whilst it doesn't have any fan noise, there are audible clicks when the drives are running, which are particularly annoying when it's running flat out to back up large amounts of data. I decided to try and come up with a way of making it quieter, so I designed a couple of suspended platforms to hopefully stop the transmission of vibrations through to the surface that it's sitting on. To test out the H2D's ability to mix materials, I designed the legs to combine more rigid PETG filament with flexible TPU. When slicing, I also selected the beam interlocking option, which provides additional surface area for better bonding between the two materials, which do actually bond together quite well. The end result is exactly what I wanted, and I genuinely really struggle to hear anything from the NAS now that it's sitting on what I'm calling the NAS damper. Let me know in the comments if you've got one of these and want the files, and I'll upload them somewhere. The mixing of materials to take advantage of each filament's physical properties worked really well in this design, and I'm sure it's going to lead to some other fun projects in the future that weren't possible before. I also printed some flip-flops in TPU, but with more hard-wearing PETG treads, just in time for the summer sun, hopefully. Now, along with the new H2D, Bambu Lab have also released two new AMS units to go with it. The AMS 2 Pro, which holds 4 spools, and the AMS HT, which holds 1. The big difference between the AMS 2 Pro and Bambu Lab's original AMS is that this new one is also able to dry filament, although there are some restrictions as to how and when you can use this function. Both of these AMS boxes are initially powered from the printer, but if you want to dry filament while the printer's running, then you'll need separate power supplies for each. The AMS HT comes with its own power supply, but I had to source one for the 4-reel AMS 2. In typical Bambu Lab style, the new AMS units aren't just the same as the old ones with some simple heaters chucked in. Instead, there are not only heaters and fans, but also vent ports that open to let any moist air out periodically. The AMSs are all controlled through the printer's screen, where you can see the humidity on the inside of each unit displayed. These new AMSs also rotate the filament while drying to prevent hot spots on the filament, which could lead to printing problems. This unfortunately means that you can't dry any filament if any of the spools inside have filament fed into the feed tubes. When I asked Bambu Lab why they can't just rock the filament back and forward with the filament loaded so that you didn't have to open the AMS after drying, they said that they found that when heated to drying temperatures, the filament could become soft enough to get damaged by the motor mechanisms when being fed through, so it was best not to dry and print at the same time. For quite a while now, I've been feeding sensitive filaments out of filament dryers like the Sunlu S4 and the iBoss Polyphemus, and I have to say I've never noticed any problems with soft filament, but in both of those instances the warm filament probably has time to cool before it's fed through any kind of extruder gears. It's not advised to feed any filaments with fibres in from either AMS, which I initially thought was because of the potential increased wear, but apparently it's because filaments with fibres are more brittle and are more likely to break inside the feed tubes. Thankfully, all of the feed tubes are now accessible from the top on the new AMS, so if you do have any breakages, they should be much easier to clear. Not that I had any problem with the AMS at all, either with Bambu Lab spools or any of the many other types and sizes I tried, including cardboard. I also completed quite a few prints using fibre filaments in the AMS, and despite the warnings, I've seen no problems so far. The AMS 2 Pro can reach a heat of 65 degrees when drying, which is hot enough to dry things like PLA and PETG, but if you want any higher temperatures, you'll need to use the AMS HT, which stands for high temperature. This single spool AMS can reach 85 degrees, which is useful for drying some of the trickier filaments you'll now be able to print with if you've invested in a H2D. Whilst the combination of an AMS2 Pro and an AMS HT gives you the ability to combine 5 different materials or colours in one print, you can actually add up to 4 AMS2 Pros and 8 AMS HTs if you want, which gives you the possibility of printing with up to 24 different filaments in one print if you so desire. There are also some other things we should probably touch on that don't really fit into my 6 video sections. If you've done any amount of internet research into Bambu Lab printers, then you may have seen that a lot of people are unhappy about some recent firmware changes to its previous models. I won't go into all of the detail, but with the H2D, Bambu Lab give you 4 different options when it comes to how connected you want to be to the Bambu Lab ecosystem. These range from isolating your printer from any networking capabilities through to going all in and letting your printer connect to their cloud services, which also gives you the ability to control your printer directly from the Bambu Studio Slicer software and even the Bambu Handy phone app. As Bambu Lab's MakerWorld site is fast becoming the go-to place to find anything that you might want to print, I find it extremely useful to be able to not only find models on MakerWorld, but also either pull them directly into the Slicer software, or if the creator has uploaded a print profile for your printer, start printing a model directly from your phone app without even turning on your computer. Trust me when I say, if you want to get kids interested in 3D printing, this is the best and easiest way to do it. My son's 12 and never took any interest in printing anything himself until I showed him how easy it is to find and print stuff from MakerWorld. You obviously need to make your own decisions about how much internet connectivity you want to give your 3D printer, but the options are there if you want them. Another thing that I haven't talked about is how quiet the H2D is. Whether running or not, it's got to be by far the quietest printer I've ever used. When it's not printing, it's silent, as you can see. This one's powered on and I can't hear anything, and when it's printing, the noise cancelling technology that Bambu Lab uses means that the only thing you can really hear is a bit of muffled fan noise and some slight motor whirring when the speed picks up. Paired with its comprehensive air filtration system, this means that you really could put your H2D in an office or home without it really disturbing you, even if you're sitting close to it. As I very briefly mentioned at the beginning of what is very likely my longest ever review, there are add-on parts that turn the H2D into a laser engraver, blade cutter and pen plotter if you want them, and it would take a whole other video to go through all of the other things you can do with it if you buy the add-ons. All I will say is that at the time of making this video, if you want the other features, you will need to buy the laser version, as there are no upgrade kits available for the 3D printing only model. However, Bambu Lab have said that upgrade kits will be available at some point. So I feel like I've spent the entire video telling you all about all of the great things the H2D can do, and it is a very good 3D printer, but it's not perfect. I've mentioned some of the negatives along the way, but just to recap, these are some of the less than perfect aspects of the H2D. Now, remember when I said about some of the bed adhesion issues that I've had? Well, I have a theory as to what may be behind my issues. In fairness, there were only a couple of prints that let go from the textured PEI surface. I didn't have any prints released from the smooth PEI, although I did use some adhesive on that plate to act as a barrier to stop TPU sticking too well. Well, as has been pointed out by a couple of other reviewers, the bed heating on the H2D's large bed is a little uneven. It's not bad by any means, but there is a little variation because of the way Bambu Lab designed the heating element. It's actually very similar to the A1's heating element, which I've taken apart myself. What I've noticed is that the area where one of the tree supports on the Mando helmet released is in one of the slightly cooler zones on the bed. Now, I may be completely wrong, but I think the bed temperature in this area may have just dipped a degree or two too low to maintain enough grip for such a tall support structure, which caused it to fail. All I would do if I reprinted this particular model would be to add a bigger brim to the supports, increase the overall bed temperature by a few degrees, or change to a different bed. As I say, the smooth bed had no problems, and Biqu have just sent me a Cryogrip Bed for the H2D, which I haven't had a chance to try yet. None of my other grumbles actually caused me any noticeable negative effects, but I think they're worth mentioning. Printing with TPU is annoying, as you need to mess around with the PTFE tubes and can't just feed it in like PLA. The hassle is worth it though, in my opinion, as the print results are so good. You can't use different sized nozzles in each hot end location yet. Hopefully this will be implemented at some point, as it would enable you to print things like supports quicker when you're not worried about what they're going to look like. Whilst I've talked about the bed being 320mm wide, it's actually bigger. But because the two hot ends are next to each other, the right nozzle can't reach all the way to the left, and vice versa. If you just think of the bed as being 320 wide, then there's no problem. But if you want to go bigger, you need to take the restriction into account. Also, I don't like that I have to expose my freshly dried filament to a potentially humid environment just to load all of the filament spools. I understand the reason for it, but I wish there was a better solution. And my last point, that's not particularly a negative, but I'd want to think about before buying the H2D, is the peak power usage. Depending on what you're going to print, in order to get the chamber, bed and nozzle all up to temperature quickly, the H2D can draw some pretty serious power for a short space of time. If you're in a lower mains voltage region like the US, you'll be heading up to the maximum allowable wattage for a main circuit when everything is running at the maximum. So you won't be able to run much else on that same circuit, let alone a second H2D, without tripping some stuff out anyway. Now, this video has been a long one, but I hope you appreciate my efforts to try and cover all of the things that this amazing printer can do. Even with over 50 individual prints complete and over 350 hours of use, I still feel like I've only scratched the surface of what's possible. Compared to what may seem to be other similar 3D printers, the H2D appears expensive, but I think when you see all of the things it allows you to do, it's obvious that it's actually pretty good value for money. Like I said at the beginning, I would never tell anyone to buy anything, but all I will say is, more than any other 3D printer I've ever used, if Bambu Lab hadn't sent me the H2D, I would be the first in line to buy one. Remember to check out the links in the description if you do decide to buy a H2D for yourself, and let me know in the comments if you want me to expand on any of the projects I've touched on in this video. There is a lot more detail I could have gone into, but this one's been long enough already. Thanks for sticking with me, and I'll see you in the next one.